You're watching The Morning Show from your local news leader.
Anthony, do you feel that vibe I'm feeling in the air? It's electric.
Do. All right.
No singing, sorry. Anyway.
All right, we are joined today with Nadia Mason, a U of I physics professor, and we are talking about static electricity, and it is actually National Static Electricity Day.
Who would have thunk?
Who would have thunk it? It's a day for everything.
It was a shock to me.
Okay, it was on Monday. I apologize. Good one. Loved it. Loved it. All right, so what do we got going on?
Okay, so now that it is winter and dry, you've probably noticed a lot of static electricity everywhere around you, right?
Yep.
In fact, I gave my daughter a kiss the other day, and we got a shock between us. And I said it added new meaning to the term, sparks flying.
Yeah.
Okay.
I like it.
That's my last pun. Okay.
I'm excited about this.
I've been working on these. Okay, so today we're going to talk about what causes static electricity.
Yeah.
So to understand this, we have to go back to our previous discussion about materials having atoms and electrons, remember? And materials that conduct have electrons that can move and conduct electricity. But materials that are insulators, like this is rod, plastic, or glass or something, have electrons that are mostly stuck to the atoms. However, if you rub that material, you can pull some of the electrons out of the atoms and even out of the material itself. And so when you pull electrons out of the material, you leave the material net positive charged, and the thing the thing you pulled it off onto has a negative charge. You can transfer that negative charge onto something else.
Crazy.
Okay, so for example, here is a insulating rod and some rabbit fur, so poor bunny.
Aww.
And if I rub this, I'm actually transferring electrons from the rabbit fur to this rod, and you can kind of hear it crackle. Do you hear that?
Yeah.
Right, you can hear it crackle. I'm transferring electrons. So you can get a little shock if you heard that.
Yeah.
If you have a little
Go for it,
crackle,
Abby.
you get a little a tiny little shock. And so that's transferring electrons from this fur onto this rod, and then transferring electrons onto you. And that flow of electrons is what gives you a shock. So I can do it, for example, with these balloons here. Let me move this over here. So we all have fun with balloons with static. And here, if I put electrons, oh God, sorry. If I put electrons on the balloons by rubbing them, so I'm going to rub the balloons with fur. So if I rub this all over with fur, I'm transferring electrons onto
can hear
this
it.
balloon. Yeah.
Crackle.
And I'm transferring electrons onto this balloon, and you can see that they go crazy, right? They're really pushing away from each other right now because the electrons have similar charges and they repel, right? So,
That one's like,
it's like crazy.
get me away from you.
So these guys repel each other because they both have electrons that I just put on with this fur. Wow. So that transfer of charges. So this is the same thing that happens to us, for example, in the winter when we scuff our feet on a carpet or something. We're transferring electrons from the carpet into our bodies, and then the next conducting thing we touch, whether it's you, charged up a little bit.
Oh, yeah, you are.
From this, whether it's you or a doorknob or something else, that flow of electricity from the accumulated charge on me to the conducting object is what gives us the shock that we feel.
Whoa.
And so that's the idea behind static. And it happens in the winter because it's so dry that we can build up charge without it leaking out into the air or other things.
Because like moisture would take that away?
Moisture would take it away because it conducts. We'll talk more about that next week. But that's the basic
tease
idea
ahead.
behind
Okay.
it. Tease ahead.
Done.
So I want to demonstrate this one other thing here.
This little mini Ferris
This little mini Ferris wheel, right. So this little mini Ferris wheel here is another way of accumulating charges on each of these balls. So when I rotate this knob, basically I have brushes that are accumulating charges from the plastic onto this metal, and they're going onto one ball. And I'm actually taking away charges from the other ball, so I get negative charges on one side and positive on the other, and then they end up flowing between them, just like they do when you accumulate charges on yourself. So you can see, as I rotate this,
Whoa.
you get a shock, right? So that's just static discharge.
Oh, man, you can see that little...
You can see it. You can see that spark. So that's just static discharge, and the same thing that we'd get, but much more, much stronger. And so what that actually is a little lightning bolt, right?
Oh
so,
my goodness.
Abby, put your finger in it. Come on.
you can rotate it, but don't put your finger. Oh my God! In fact, now I'm going to grounded just because you said that.
Yeah, keep me safe. I'm gonna go stand
Keep
over
you safe.
here for the rest. Maybe hide. No, I'm hiding behind the balloons.
I am the balloons, right?
Fine, I'm just got my eye on you now.
The cool thing is that what looked like a lightning bolt looks like a lightning bolt because it is a lightning bolt.
Wow.
So the idea behind a lightning bolt is basically a really scaled up version of static discharge, right? Wow. So for lightning, in the clouds, the ice particles are insulating. They rub against each other. You get the electrons separating out from the positive charges, and then the electrons either recombine with the positive charges. That's the lightning bolt you see in the clouds, or they flow to the ground, and that causes that bolt. And so lightning is just a scaled up version of this. It's about 1 billion times stronger.
I think that it would hurt a little bit more if lightning hit my finger.
It would hurt a little bit more, but it's basically the exact same thing. So next time you shock someone, just think about you're creating your own little bolt of lightning.
Okay, I do have a question that maybe you'll answer next week. I'm not sure,
Yes.
but sometimes, like at family parties, I'll take a balloon and rub it on the top of my head and then stick it to the wall.
Right.
Why does that happen?
Okay, so I will talk about that next week, actually.
week. See, jump ahead.
No, but it's basic same idea is that you're accumulating charges on this. You have extra charges, and the charges are then attracted to the charges so think of atoms on the wall of having lacking charges in some sense. And so the ones on here end up being, I know you can see it, they end up being attracted to the wall and they stick there. So positive and negative charges attract each other, and that's what you get there. And so next week what I'll talk about is well, it'll be all balloons, and I'll show how you stick it to the wall, but also how you can prevent static discharge. Things like dryer sheets make things more conducting in water, and so we'll play with that.
Oh, man. Love having you here, Nadia. Thank you so much. I'm going to play with this thing in the commercial.
And I'm going to walk away.
But we'll be right back.
There you
Here
go.
Here we go.
There you go. Go ahead. Go ahead. Good one. Look at that.
Not bad.
Your own lightning. That's pretty cool.